Assalamualaikum and good day everyone. I'm Madam Nurhidayah binti Ahmad from Physics Unit KM20. Today we will learn chapter 10. The topic is mechanical and sound waves. I will cover subtopic 10.1 which is properties of wave, 10.2 superposition of wave, and 10.3 sound intensity. And my friend will cover chapter 10.4 and 10.5. So, this is the overview of this topic. It is divided into several parts, which is physical parameters, types of wave, which is divided into two, transverse wave and longitudinal wave, and we have superposition of wave. And then for sound intensity, we have sound. For sound wave, we have sound intensity, stationary waves, and Doppler effect. So now let's go to progressive wave. What is progressive wave? Progressive wave is the wave that move outward from their source. The progressive wave is also known as traveling wave. There are two types of progressive wave, which there are transverse wave and longitudinal wave. Progressive wave has definite speed called the speed of propagation, or we can call the wave speed. Okay, we can call the wave speed, which is v. The direction of wave speed is always the same as the direction of the wave propagation. So here is the types of progressive wave. First we have transverse wave. Transverse wave is a wave whose direction of vibration of particle is perpendicular to the direction of the wave propagation. As you can see in this GIF image, the particle is vibrating upward and downward, and then the direction of the wave propagation is to the right. So we can say here that the direction of particle vibration and the direction of wave propagation is perpendicular each other. Okay. The example of transverse wave are water wave, wave on string, and electromagnetic wave. So then we will have a longitudinal wave. What is longitudinal wave? Longitudinal wave is a wave in which the direction of vibration of particle is parallel to the direction of wave propagation or wave speed, as you can see in this GIF image. So here is the differences of the two waves in table. I hope it will more easier for you to understand. For transverse wave, again, is the direction of the vibration of particle is perpendicular to the direction of the wave propagation, as you can see in this image. And then for longitudinal wave, remember that it is the direction of vibration of particle is parallel to the direction of the wave propagation, as you can see in this GIF image. The examples are shown below. This is the types of wave. We have transverse wave and longitudinal wave. You can make this experiment yourself at home. Okay, so now let's move to 10.1, which is properties of wave. At the end of this chapter, you should be able to define wavelength and wave number, solve problems related to the equation for progressive wave, where y is equal to a sin omega t plus minus kx. You also have to discuss and use particle vibrational velocity and the wave propagation velocity. And the last one, you have to discuss the graph of displacement versus time and displacement versus distance. In this figure, we can see the sinusoidal wave, where we have crest or peak. What is crest or peak? A crest is a point on a wave which has the maximum value of upward displacement within a cycle. We also have trough. What is trough? Okay, what is trough? Trough is the lowest part on the wave, right? The horizontal distance between the two adjacent crest or trough we call the lambda or wavelength. Okay, remember that the horizontal distance between two adjacent crests, okay, or trough we call lambda or wavelength. This is the water wave diagram. As you can see here, we have crest. Okay, we have crest and also trough. We have crest and trough, where the distance between point A to B we call one wavelength. We call one wavelength. And the time required for the wave crest at point A to reach point B we call the period. Okay, we call the period, where the period is the time required for a wave crest at point A to reach point B. Here is the explanation for the wavelength. Okay, wavelength. As you can see here, again we have crest and also trough, where the distance from crest to crest is one wavelength or one lambda. Okay, the distance from equilibrium to this equilibrium, where we have one oscillation, is also lambda or one wavelength. Distance between trough to the other trough is also lambda. Okay, so as you can see in this image, we also have amplitude. What is amplitude? Amplitude is the maximum displacement from equilibrium position to the crest or trough of the wave. This graph shows the wavelength and period. If you have y versus x, so then your distance from crest to crest we call the wavelength. If you have y versus t graph, so then the time taken to make one oscillation from crest to crest we call the period. Okay, so this is a few quantities and its definition, where we have displacement. What is displacement? Displacement is a distance moved by particle from its equilibrium position at every point along the wave. So then we have amplitude. What is amplitude? Is the maximum displacement from the equilibrium position to crest or trough of the wave motion. So this is the amplitude from equilibrium to crest or equilibrium to trough. The unit is meter or centimeter. So then we have frequency. What is frequency? Is the number of complete cycle that pass a given point per second. The unit is hertz or per second. So then we have period is the time taken for the particle to complete one cycle of its oscillation, or the time for the wave to travel one wavelength. So this one we call period, right? So the unit for period is second. So then we have angular frequency, where is the rate change of the phase of the sinusoidal waveform. The unit is radian per second. We also have wavelength. Wavelength is the distance between two successive crests, or distance between any two successive identical points on the wave. So this is the wavelength. Okay, we call the wavelength. So a distance from equilibrium to equilibrium takes one complete oscillation, or the distance between crest to adjacent crest we also call the wavelength, or from trough to trough we call the wavelength. Remember, wavelength is the distance between two successive crests or two successive troughs. Then we have wave number. The wave number is the number of waves exists in 1 meter, where the unit is per meter, where the formula for wave number is 2 pi over lambda. This is the formula for wave number. Wave number is defined as the number of waves exists in 1 meter. This is the formula for wave number, and the unit is per meter. Next, we have 10.1b, where you have to solve problems related to the equation for progressive wave, where y is equal to a sin omega t plus minus kx. This is an equation for progressive wave. We have y xt is equal to a sin omega t plus minus kx, where y is the displacement of particle from its equilibrium position, x is a distance of particle from origin, t is time measured in second, the amplitude of the progressive wave measured in meter or centimeter. We have angular frequency, which is radian per second, and we have wave number in per meter. So this is the equation for progressive wave. There are two equations here, where we have y is equal to a sin omega t plus kx. So this plus shows that the wave is propagate to the left, and the other one we have y equal to a sin omega t minus kx. This minus shows that the wave is propagate to the right. So you have to remember, this one is the alternative equation of the progressive wave. We have y is equal to a sin omega. So omega you can substitute with 2 pi over t, and k, which is wave number, you can substitute with 2 pi over lambda. So here is the three equation that is alternative to right equation for progressive wave. Number 1, number 2, and number 3. You only have to substitute into the formula. So then, number 10.1c, we have to discuss and use particle vibrational velocity and the wave propagation velocity. So this is the derivation for particle vibrational velocity. From the definition of velocity, we have Vy is equal to dy over dt. So then you have to differentiate. D over dt is equal to a sin omega t over kx. So we have Vy is equal to a d over dt. We have sin omega t plus minus kx. So you have Vy equal to a omega cos omega t plus minus kx. So this is the formula for particle vibrational velocity. For particle vibrational velocity, okay, as I mentioned before, V is equal to a omega cos omega t, where V is the vibrational velocity of particle, x is a distance from origin, t is time, a is amplitude for progressive wave, omega is angular frequency, where omega is equal to 2 pi f, or equal to 2 pi over t, and the wave number k is equal to 2 pi over lambda. Here is the wave propagation velocity, where for the velocity for the wave propagation, we have v is equal to f lambda, or we can have v is equal to lambda over t. This is the derivation from the wave propagation velocity. From the definition of velocity, we have v is equal to s over t. So s this is a distance. So 1 lambda is our distance, and t is time. We have period, where period is the time taken to make one oscillation. So then we have v is equal to f lambda. So this is the comparison of the two particle vibrational velocity and the wave propagation velocity, where for the particle vibrational velocity, you can see that this particle is moving up and down. So this is the velocity of particle which oscillate about equilibrium position in simple harmonic motion. By differentiate the displacement equation, so then you have Vy is equal to V omega cos omega t plus kx, or you can have Vy is equal to A omega cos omega t minus kx, where plus shows that the wave is propagate to the left and minus shows the wave is propagate to the right. So then we will have wave propagation velocity. For the wave propagation velocity, okay, wave propagation velocity is the v is the velocity at which the wave crest or other part of the waveform move forward. Alright, so figure shows the trough travels a distance of one wavelength in a time equal to the period. So we have v is equal to s over t. Okay, s over t. So we will substitute. Here we have the distance is lambda and the time is period. So the formula for wave propagation velocity, v is equal to f lambda. This is example 10.1. Okay, figure above shows the wave profile which t is equal to 0 second for the sinusoidal wave travels in a straight line to the right. Okay, to the right, a constant speed of 10 meters per second. So you have to write the equation to represent this wave. So we have v is equal to 10 meters per second. We have amplitude is 0.2 meters. We have lambda equal to 1 meter. Okay, the amplitude here is 0.2 meters. And our lambda is from equilibrium to this one, we have 1 wavelength. So you have to find the frequency first. Okay, so the equation for progressive wave y equal to a sine omega t minus kx. Minus means the wave is propagate to the right. So to find omega, we know that omega equal to 2 pi f. Okay, so we don't have f, so we have to find f. We have v is equal to f lambda. So f equal to v over lambda. Our v is 10 and our lambda is 1, so our f is 10 Hertz. Okay, so our angular frequency omega equal to 2 pi f. So we have 2 pi, our f is 10. So we have our omega is 20 pi radian per second. So then you have to find the wave number, where the wave number k is equal to 2 pi over lambda. So 2 pi, our lambda is 1, so we have 2 pi per meter. So you have to substitute into the equation omega t minus kx. So then we have y is equal to, okay, y is equals to a is 0.2 sine 20 pi t minus 2 pi x. Alright, where y is in meter and t is in seconds.